Linux file systems. In this nugget, we're going to delve deeper into Linux file systems. We'll start by going through the steps to relocate a file system. This is useful if you're running out of disk space and you need to extend the storage capabilities of your Linux system. We'll walk through the steps from installing your new drive to copying files and making that new drive a permanent part of your system. And then we'll conclude the nugget by looking at how to create a test file system so that you can experiment without any fear of irrevocable damage. So pull up a chair and let's get started. Our first topic for this nugget is going to be relocating a file system. So take the following scenario. Say you've got one hard drive on your system and you're running out of disk space. And so what you need to do is you need to install a new hard drive and move some files over to that hard drive to, so that you have more space to grow. All right, so the first thing that we need to do is we need to install a new hard drive on our system. And just say that our first hard drive is called /dev/HDA, and so our new hard drive is going to be dev/HDB. If we're talking about SCSI disks, then of course this would be SDB, and our first drive would be STA. Okay, so once we get the new hard drive on our system, then what we need to do is format it and create a partition on that hard drive. And then what we need to do is we need to move files into it. And just say that we choose the /home directory as the files that we're going to store on our new hard drive HDB. Okay, once the files are moved over there, then what we need to do is we need to associate /home with that partition on our new hard drive permanently, so that when we boot up our system, that hard drive, that partition on that hard drive that we create will be associated with /home right when we boot up. All right, so that's the scenario that we're going to walk through. Now let's get into some details on how we carry this out. So the very first thing that we need to do is we need to do the, the hardware portion of the process, namely install the new hard drive. So if you're not comfortable messing with, opening up your computer and plugging stuff in, then take it down to your local computer shop and have them do it for you. But it's not too difficult of a process to install a new hard drive. Just make sure everything's unplugged and turned off. Mount your new hard drive in there. Make sure all the mounting screws are secure and everything like that. And then make sure that you double check the jumpers on the hard drive. The way that I'm describing this scenario is that we have a hard drive HDA. That would be what's called the master drive. And then the new drive that we're setting up would be dev/HDB, and that would be the slave drive. And typically the cables that connect to the hard drives have 2 plugs per cable, and then one of the plugs, the other end of the plug goes in the motherboard. Okay, so double check the jumpers to make sure that the new hard drive is set up to be the slave and not the master. That's a common problem that people just forget about, and their new drive is not recognized if you don't set the jumpers correctly. Another issue that you might run into is modern drives can be really, really large, and old BIOSes were never expecting the hard drives to be so large, and so sometimes old BIOSes can't recognize really large drives. They're just too large. The BIOS can't address all of the tracks and sectors on the hard drive. And so there is sometimes this incompatibility, but there are ways around it in Linux a lot easier than for other operating systems. If you do run into this problem, do a Google search for large disk how-to. Okay, and if you do this Google search, you're going to see all sorts of documents out there, that mainly the how-to page for how to deal with large disks and old BIOSes, and it'll walk you through various steps that you can take to make sure that your large drive is recognized by your old BIOS. If neither of these are the problems and your new drive is still not being recognized by the hardware, by the BIOS, then what I would recommend doing is taking your functioning disk offline. Okay, just pull out that disk offline, use that plug that you used for your old disk initially, plug it into your new drive, and set the jumper for your new drive to be a master. Okay, so now you're using the exact same plug that you had before, and you're checking it sort of all by itself. So you're just doing like the scientific process here. You're eliminating variables, and you're getting down to what can be the problem. Is it the plug that's the problem? Is the new drive not functioning? Is there could be an incompatibility between the 2 disk drives. Sometimes the 2 disk drives on the same cable don't like each other, they don't communicate well with each other, and so then there's problems that get run into there. So it would just be nice to narrow down your problems and walk through those. Like I said, 99% of your problems are going to be taken care of by jumpers, or if you have an old BIOS, this could be one possibility for a problem. So once you get that new hard drive installed and recognized on your system, then the next thing that we're going to do is we're going to create a partition table and mount it. All right, so to create the partition table and mount it, we use the make e2 fs command. We're going to use that command with the -j option. And remember from the intro series, the -j option is the journaling option. So basically it makes an ext2 file system with journaling, which is the same as an ext3 file system. All right, so we're going to make this file system, this ext3 file system, on /dev/hdb1. So we're creating one partition on the new hard drive, and we're calling it hdb1. Notice here I've also used the -c option. The -c option, it checks for bad blocks. So when you are formatting this hard drive and creating this partition, the bad blocks are looked for. So this is going to slow this process down to a snail's pace, okay? But it's worth it because if you check for the bad blocks when you first format and partition this drive, then those bad blocks will be flagged and they won't be used by the disk. Okay, if you don't check for bad blocks, then what you run into, the possibilities of danger that you run into, is that there is a bad block there, that physically something is wrong with the block right out of the manufacturer, and you copy data onto that bad block, then the data that you copy onto that bad block is corrupted and you might end up losing some data. All right, so while this -c option will slow this process down to a snail's pace, it's worth it to do it then because you're going to have more peace of mind that the data that you're copying over there is okay. All right, so once we've created this partition and formatted it, then what I want you to do is make a directory and name it /mount/drive_b or whatever you want. This is just going to be a temporary mount point for this partition so that we can copy files into it, right? Because eventually what we're going to do is make this partition associated with /home. But for the interim, we're just going to make it associated with this drive B mount point so that we can copy files from /home into there. All right, and then what I need to do is I need to mount that file system. So I'm going to say mount -t ext3. So -t is the type of the file system, and it's an ext3 file system because we use the make e2 fs command with the -j option, remember. And then I associate /dev/hdb1 with /mount/drive_b. This whole thing here should be on one line. I just couldn't fit it because my writing was too big. So here what we're saying now is that hdb1 is associated with mount drive B. Now once we've got that set up, then what we can do is copy files from the /home directory to this mount drive B. All right, so I'm going to say copy -a home /*, the asterisk, so that everything from the home directory is copied over there, and the -a says to keep all the permissions, the modification dates, the ownership, everything. Keep all that the same during the copy process. Okay, don't turn everything into like root ownership or something. Now there's other ways that you can copy stuff. You can, use the tar command and pack it up in a tar ball and move it over and unpack it or whatever. There's all sorts of ways to do this. This is just one possibility for you to copy stuff over. So now, what's the state of the world right now? Well, on our drive A, there is a /home directory that has all these files. On mount drive B, there's a /home directory that has all those files too. But if I say cd/home, I'm going to drive A still, right? Because I haven't made any changes to the file system table to associate the /home directory with my new partition. Okay, so to make that association between /home and my new partition permanent, I need to modify the etc fs tab file. And we talked about this configuration file in the intro series. So the way that I do that is I add a line to the fs tab file in the etc directory, and it says /dev/hdb1 space /home space ext3. That says what kind of file system I'm associating with it, and I'm just going to use all the default options. So this says that the /home directory is now mounted on this partition /dev/hdb1. But this will only happen after I reboot. Okay, so by putting this in the file system table, I'm preparing for the next reboot that slash home will be associated with this. But before I reboot, I want to do a couple tests to make sure that everything's functioning. So this is the test that I want you to run before you reboot. Okay, I want you to cd to slash home. Now, as a little quiz, where is this? This is living on HDA. Okay, so let me draw a little diagram over here. Here's HDA. On HDA is a little section that is slash home. Okay, over here is HDB, and on HDB is just one big partition, and all the stuff from the home directory has been copied there, but you know, it still lives over here on HDA. So when I say cd slash home, and because I haven't rebooted, then you know the old file system table is still in effect. I go to the directory on HDA, the home directory. Then what I'm going to do is I'm going to say touch and make up some big file name in all capital letters that will really stand out. So say touch old home partition or whatever you want to call it. Okay, this, remember the touch command just creates an empty file. And so it just creates an empty file with this name. This name is where? This name is on HDA. So now there is a file on HDA that's not on HDB because I'm creating this file after I already copied the whole home directory over to HDB. Okay, so this file lives on HDA. Then what I want you to do is unmount /mount /drive B. Okay, so now HDB1 is not associated with this mount point anymore. So all this stuff is out here, all the data's out there, but there's no way to get to it right now. And now I'm going to mount that dev HDB1, that partition over here, and I'm going to associate it with /home. So this command here just does it, you know, for this particular session, okay? And when I do that, then what I want you to do is go to the /home directory and do an ls, or say ls/home. All right, now what you're going to get is you're going to see all the files that were in the home directory, but you're going to be seeing them over there. What you will not see is this file that you just created, old home partition. Okay, because that's on HDA. So when you switch over this mount point, when you say home is now associated with dev HDB1, and you do this listing, you're going to be looking on the brand new thing. So poke around in there, look for files, you know, open files, edit files, do whatever you want, and everything should be functioning correctly. Once this test is satisfying, you know, once you've said, okay, all the files are there, it seems like all the permissions are right and everything's all set up, perfect, okay, then you can go ahead and reboot, and then that file system table entry that we made here will then kick in, and dev HDB1 will be mounted to the home directory, will be associated with the home directory permanently, okay? Even after you reboot, all this stuff still lives on HDA. Okay, that whole home directory is still there. It's just not really accessible because when I go to /home, that command that I put in the fs tab file takes me to HDB1. Okay, if there is something wrong that you notice, oh, the permissions are wrong or something's wrong or whatever, there's some files are missing or something like that, then, you know, you have a fallback plan. All those files are still on HDA, and that's perfectly fine. Like I can go back and look at these, you know, and make amends for the problems. Once you're satisfied that everything is okay, then you can go ahead and delete all of this stuff on HDA and reclaim all of that space because now it's inactive. Well, this is a little part of the show that we like to entitle Fun with File Systems, okay? And what we're going to do here is we're going to set up sort of a fake file system on our computer that we can mess with to our heart's delight without potentially damaging any aspect of our system. So this is the problem with file systems is, you know, to really learn about file systems, you got to go in there and do things, but you don't want to like break stuff on purpose. You don't want to take a screwdriver to your disk drive, or, you know, you don't want to just go through and start deleting like big hunks of files that are useful on your computer. So it would be nice if we could have some sort of test system, and we can do that, and I'm going to show you how to set that up. What we're going to use here is what's called a loopback file system, and you probably haven't heard of that before, and that's okay. I'll take you through all the steps and show you how to create a loopback file system, and basically what this is going to do is it's going to be a file system that's contained in a single file on your computer, but it's going to look like a file system in every way to you when you mount it. Okay, so the first thing that we have to do here is become the root user. So I'm going to switch over to be the root user, and then I'm going to go up to the temp directory, and in the temp directory I'm going to create an image file. Now I'm going to use the dd command to create this image file. This is a command that we use to in the past, we've used it to create images on floppy disks, like boot images and things like that. But right now, what we're going to do is we're just going to create basically a blank file system in a particular file that we're going to name. All right, so our input file is going to be dev/0. Now, this is a special device in the dev directory, the 0 device, and all it does is spit out zeros. So when we use that as our input file, our image is going to be just a bunch of bytes, and they're all going to have zeros in it. There's not going to be any ones in any of those bytes that we're creating. So we're just creating basically a blank slate. Okay, and our output file here, we're going to call it temp slash, let's call it file system test.image. Okay, now you can name this whatever you want, and this is going to be an image file that is going to contain, it's going to be blank at first, but it will behave just like a file system when we get all done. All right, we can specify the block size. So here I'm going to specify a block size of 1024. Okay, that's 2 to the power of 10. All right, so it's nice to pick block sizes that are powers of 2. 512 or 1024 would be common. Like on a floppy drive, for instance, the block size is 512, and there's 2,880 of those blocks on a floppy. We're just going to create a block size of 1024, and let's make 5,000 of them or something. Okay, and again, you can make as many as you want. You have to have room on your hard drive to handle a file that is this large, right? This is 5,000 blocks, and each block is 1,024 bytes. Okay, so that can be, that's if I made this 100,000 or something, that could be too large for my system. So you need to keep track of how much free disk space you have and so on, because this file will eat up disk space. All right, so I'll hit enter here, and it says 5,000 records in, 5,000 records out. Now we've created this file, and we're in the temp directory, and there it is, fstest.image. Okay. We can also examine other attributes of this file that we just created by using the file command on that file. And if we say file/temp/fstest.image, then you can see it just spits out that it's a data file. Okay, so right now the operating system thinks that that thing that we created is just some large data file filled with zeros. It has no reason to think that it's some sort of loopback device or anything like that. Okay, so what we need to do is we need to use the lo setup command to create a loopback device. All right, so what I will do here is I'll say /dev/loop0. This is something that already exists in the dev directory. There's loop 0, loop 1, loop 2, up to loop 9 or 10. And you can pick any of those loopback devices and associate them with the image that you just created. Okay, so here I'll say file system test.image. Now when I do that, now I'm saying that this image that we've just created is now associated with the loopback 0 device, with the loop 0 device in the dev directory. Now what we can do is we can make a file system on there. We can say make e2fs, you can make an ext3 file system, whatever you want. It's totally up to you. If you want to play around with different kinds of file systems, like maybe you want to play around with the riser file system in this image that you've created, go ahead. You're not going to mess anything up. That's the beauty of this whole loopback device thing that we're trying to create here. So here's what I'm going to say is I'm going to say /dev/loop0. So I'm going to make an ext2 file system on that loop 0 device. And here's the output. Here's what's happened. Make e2fs has all sorts of options. I could have given this thing a label and so on. Notice here it says the block size is 1024. There's 1,256 inodes. There's 5,000 blocks. So that was the 5,000 came from that command. When we created that image, we said create 5,000 blocks, each block of size 1024. That was in the specifications to the dd command. Okay, and here's all sorts of other things that happen. There are 250 blocks, 5% reserved for the super user. There's one block group. There's, inode tables have been written. The super blocks and the file system accounting information was done. Okay, so all of this stuff was happened when we made this, and now we've got this file system on this device loop 0, and all this loop 0 is this file that lives in the temp directory. Okay, so this is what we're doing now, and you can play around with anything you want at this point. What we're going to do now is actually mount this file system so that we can go in and create files and delete them and so on. So before we actually mount our file system, I just want to run the file command again on the image that we created in the temp directory. And now you can see that it doesn't just say data after that image file anymore. It actually says it's a Linux ext2 file system. So now the operating system looks at this as an ext2 file system, and it will behave just like any other file system that you run across. Okay, even though it's mounted really as this loopback sort of file system. All right, so now let's actually mount this file system so that we can go in and play with it. And the way that we do that first is we have to create the directory in the mount subdirectory, and let's just call it fs test image or something. Okay, and again, you can name this whatever you want, and I'm going to create that directory, and then I'm going to associate the device loop 0 with that mount point that I've just created. All right, so I do that, and now we have a file system, and it's mounted on our computer at mount/fs test image. So we can do whatever we can do to other file systems. We could say df-h mount fs test image, and that will tell us information about the disk usage of our file system, what it looks like. So the file system is loop 0, the size is 4.8 megabytes, 13 kilobytes are used, which is about 1%, and it's mounted at the mount point /mount fs test image. What's that 1% that's being used? Let's go look. So we can go into the mount/fs test image directory, do an ls, and we can see there's a lost and found directory in there. That's created automatically when you create the file system. Remember, the lost and found directory is where orphaned files are put by the operating system. So if you're doing some sort of file system check or restoration and files are found, they're not necessarily corrupt, but like the pointer to the file is gone. So it doesn't have a parent in some sense. That's why I said orphaned files go in there, for lack of a better name. And so that directory is created automatically. That's part of the 1% that is used of the overhead that's used when the file system was created on our test image. Okay, and now we can go do whatever we want. We can add files, delete files, we can just wreak havoc on our system. And if you want to play around and mess with file recovery, or you see some Linux article one day that tells you some slick way to recover lost files, well, you test it out in this sort of situation and you have nothing to lose. The worst that can happen is you just delete this file and you start over again. All that you're doing is eating up like 5 megs of your disk space, and on a 40 gig drive, who cares? And you can create even bigger file systems with more space if you need to test out something on a larger scale. Okay, if you want to unmount this, all you have to do is say umount, and then you can just say mount/fs test image, and that will unmount the file system. Notice it says device is busy because I'm actually in the fs test image directory, so it won't let me unmount it. But if I go back a directory and then try to unmount it, now it's unmounted. If I go back into the directory that I created and do an ls, you'll see nothing's there. The lost and found is gone because now I've disassociated the actual device loop 0 with this mount point mount/fs test image. All right, so there you have it. There is a file system device that you get to play with, and if you're like me, I learn a lot more by experimenting with things, and so that's why I seek out ways like this to create sort of test devices and things like that, ways that you can play around without really messing up your system at all. Okay, now if I want to remount things again, I have to do things a little bit differently the second time around. So here what I'm going to do is I'm going to remount the file system, and instead of going through all the steps before, I'm going to do it slightly differently. I'm going to use the mount command with the -O loop option. So this is saying mount this loop device, and I'm going to associate that image that we created in the temp directory with the file system test image directory under /mount. Okay, so I do that, and now I'm mounted again. And if we go in there and do an ls, you'll see the lost and found directory is back. And so we're all mounted up again. And now what I can do is I can do things like, dump e2fs with the /temp/fs test image. Okay, and now we can look at a dump of the file system. Okay, so and you can learn about all sorts of things that are going on in the file system, the blocks, the inode requests, or the number of inodes that are used, and all sorts of other things. And so if you want to delve into, the internals of what's going on with the file system, dump e2fs is a good way to do that. And you can, like I said, you can do anything you want on this file system. It's just like any other file system, and it's a good way to get practice on your file system commands. All right, well, it's time to wrap up our nugget on Linux file systems. In this nugget, we extended what we talked about with regards to file systems from the introductory series. And we talked about two major things. The first thing was, how do you relocate a file system? So when you need to add to the storage capabilities of your Linux system, I walked you through the steps on how to do that. Everything from installing a new drive, to formatting it and partitioning it, to copying files over to it, to mounting it, to making it a permanent part of your system. And remember, to make it a permanent part of your system, you have to modify the configuration file in the etc directory called fstat. That's the file system table. And if you add an entry to that for your new partition, then every time you boot up your system, it will be recognized and be part of your Linux system from boot time. And then the last thing we talked about was, how do we create a loopback file system? This is a special kind of file system that basically allows us to have a file system contained in a single file. Okay, the operating system acts like it's a file system, so you can play around with it, you can mount it, you can unmount it, you can create files on it, you can do whatever you want to it, and it basically lets you test things out in some sort of experimental fashion without having the dangers of messing with the real file system. The worst that can happen here is you just delete the file system, the loopback file system, and you start over, and there's no other major changes that you need to make to your system. Well, I hope you found this nugget informative, and thanks for watching.